So we're going to do some graphs now. And I realize on your note page, if you're using the guided note page, you don't have these extra grids, but this is just for demonstration purposes. Okay, so let's say we have the points, -3, 0, and 0, 0, and you know what? I don't want those. I'm changing it. Okay, so let's say we have -3, 2, and 0, 2, and 4, 2. Let's say we have those three ordered pairs, and let's graph them in blue. So -3, 2 would be the point right there, and 0, 2 would be the point right there, and then 4, 2, 1, 2, 4 to the right, and 2 up would be right there. And do you see how all of those points are lying on this horizontal line like that? And notice that all of them have a y value that equals 2. Well, that's the equation of the line. So when you have y equals just some number, some constant, and there's no x term, you're allowed to have that, and there's no x term, you just have y equals a number, that's going to make a horizontal line. And it's going to be at that number. So y equals 2 in our example, you say, oh, y equals 2, that's my equation. That's going to make a horizontal line, and it's just going to graph right at 2. That's where all the ordered pairs have a y value of 2. Okay? Now, similarly, if we had something like 3, -4, and 3, 0, and 3, 5. If we had those ordered pairs, well, we can graph those. We'll graph them in green here. So you go over 3 and down 4, 1, 2, 3, 4, right there. You go over 3 and you go 0 up and down, so it's right there on the x-axis. And then 3, 5, 3, go to the right, 3, and up 1, 2, 3, 4, 5. We're always starting from the origin when we graph these ordered pairs. Okay, and so you can see those lines, or those points, they line up and make a vertical line. Okay, and notice that all the x values, in this case, are 3. And so when you have an equation that's x equals some number, and there's no y term, that's going to make a vertical line. Okay, so our case, we have x equals 3. This is the equation for that line. It's where all the points on that line have an x value of 3. So hopefully it makes some sense. It's kind of a little memory thing. You might want to make yourself a little note card of some of these facts that'll help you as we move along. Okay. So example 5, graph the equations. All right, so the first equation, x equals 5. So like we talked about, see, this is the memory part. Oh, when I have x equals a number, that's a vertical line. Vertical. And so you just count 5. It's positive 5, so 5 to the right, 1, 2, 3, 4, 5. And you make a vertical line. You can do a table of values, but x is always going to be 5. Y, it doesn't matter what y is. Y can be any number, but x is always 5. Anyway, and sometimes it helps to do that, to come up with some ordered pairs where x is always 5, and then you'll see it's a vertical line. Okay, so now the next one, we have y equals -4. Okay, so it's going to be a horizontal line. Did I have a memory trick? Horizon, like y? I don't know. I don't have a memory trick. But it's going to make a horizontal line at -4. So you go to -4 on the y-axis. 1, 2, 3, 4, 5. Maybe that's the way to, or I went 5, didn't I? Maybe that's the way to remember it. Because it's y equals -4, you go on the y-axis. Okay, and then it's going to be a horizontal line. So it's going, okay, I can't draw a straight line. No, that's what it looks like. Okay, and that's how we graph those. So they're kind of special lines. It's when it's missing an x term, then it's a horizontal line. If it's missing a y term, or there's no y term, then it's a vertical line. Okay. Graph the equations in the same rectangular coordinate system. Okay, so they're making a point here. On the first equation, you have y equals negative 3x. Now, that has both a y term and an x term. So this is going to be a line. It's going to be very, very cute. We're going to make a table of values because so far that's really all we know how to do. And we'll just put in some numbers, negative 2, 0, 1. Those will be adequate. So I'm going to find those three ordered pairs. So I'm going to say y equals negative 3 times negative 2, or y equals 6. So I'm plugging in, I think I numbered them before. I think so I'm plugging in negative 2 for x, and I'm getting 6 for y. So you're finding the match that goes when x is negative 2. All right. Second one, we're going to let x equal 0. Now, where did I come up with those numbers? Negative 2, 0, and 1. I just made those up. I just picked some fairly small numbers. 1 negative, I picked 0, and I picked a positive. Okay, so we get y equals 0. And then the third one, we're going to let x equal 1. So you get negative 3 times 1, which is going to be negative 3. Okay, now these are the ordered pairs then we're going to be graphing. Negative 2, 6, so go left 2 and up 6. Right there. And then 0, 0, that's the origin. Okay, this is the origin. So it's an ordered pair. It goes right through the origin. And then 1, negative 3, so go right 1 and down 3. Now it is a linear equation. They should line up. They do. And so it looks like, kind of like that. Kind of like that. Okay, that is that equation. It has an x term, it has a y term, and it happens to go through the origin. Okay, we'll talk about that more in some other examples in a while. The other one, so let me get a different color. I don't know what color shows up best for you, but y equals negative 3. Okay, that doesn't have an x term. It only has a y term. So this is a horizontal line. So you're going to go to negative 3 on the y-axis, 1, 2, 3, right there, and just draw a horizontal line. Okay, so this is the equation y equals negative 3. This is the equation y equals negative 3x. Okay, so they're two different lines, so don't get that mixed up. I think that's why they put this problem in there, to kind of point out the difference between the two lines. Okay, so every line that we're given will match to a particular equation. And we have two different equations here, so we have two different lines. Okay,